Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westmeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode. Hey guys, I want to take 2 seconds and talk about thermostatic expansion valves, specifically made by Sporlan. How you can always have the right TXV for the right application without having to carry hundreds of TXVs on your truck. Use a Sporlan's interchangeable cartridge style Type Q conventional and Type BQ balance port TXVs. It's easy as 1, 2, 3. It serves about 1,000 different unique applications. All you have to do is select the body, select the cartridge, and select the power head for it. These easy to select and assemble valves means that you always carry the right valve for the right job. For more on Q and BQ TXVs, visit www.sporlan.com. Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel and Kevin Compass. How's your week going? You look great.
I'm on week number 3 of 16 and 18-hour days, and I look like shit, feel like shit, and I hate this job right now. Yeah, I'm on a startup from hell. I don't think there's anything that's gone right on this job, and they just keep pushing harder and harder and harder. I'm playing the OEM, the startup guy, the EMS guy, and the HVAC guy.
So are you I wanted you to bring this up the other week, and I was on the HVAC overtime show, and they wanted me to talk about this, but it was your kind of gig, so I wanted you to kind of basically talk about your pump problem, because I had never seen anything like that before in my whole entire life. You know, I was racking my head when you called me.
Oh, we started up 2 brand new glycol racks, but they're off one pump skid, and everything was going okay, minus the 45, leaks the hall guys had, and all the other random BS that happened, and crisscross lines, from people not paying attention, mostly the hall guys. And everything was going good, and then we started the pumps up, and they started overamping like immediately, and we were like 200-300 gallons still short on glycol from what we should have had. And we were going through stuff, and we're racking our brains. 14 hours, me, my other startup guy, and the construction foreman are on site. We're going through everything with the OEMs there, and finally, at one point, my other startup guy started ripping insulation off the pump and realized that that pump is stamped with a custom impeller size on it, which they all use the same impeller size for this customer generally at every store they do. And we're going through stuff and trying to figure out stuff, and taking pump pressures. Pump pressures are all jacked up. I had like 90 feet ahead. Couldn't cut the flow back at all, like even with the triple duty valve. No matter what I did, unless I cut the triple duty valve back all the way, we couldn't get like proper flow. I mean, I was flowing like way more. My suction pressure in the pump was messed up. My discharge pressure in the pump was through the roof. We were shaking the piping. I mean, it was just violent. Everything was happening. It was overamping. So we started going through some stuff, and I mean, we had high amp draw on the pumps. We had high differential. We had high pump head. I mean, everything to me. I mean, I never really seen an oversized pump. I mean, most of the pumps I worked on, glycol stuff's been like, carefully sized, and then other big building stuff. I mean, you're talking 30-story high rises. I mean, that's a lot of pumping. So, I mean, I've never seen a pump physically overamp a centrifugal pump. Usually a centrifugal, once you spin it, against too much, it usually flatlines, just like a blower wheel. But this, I mean, these motors were smoking. I mean, they were like, the one motor was 235 degrees after running for like 10 minutes. I mean, it was getting ready to burn up. Like, so we started going through some stuff, and then pulling the pump out. We ended up doing some calculations, and the impeller that was on that pump was a 7.5-inch impeller. That's what it came from the factory, and they were supposed to get turned down to a 5.25 or 5.75 to reduce the flow on that pump. They still need that horsepower to turn against the glycol, but they need that smaller impeller to move less flow. So what ended up happening is we ended up doing some math, and if it had the 7.25 in there, it ended up moving like 230 more GPM than we had, which was essentially almost 3/4 of the flow of the actual rack. So we were almost flowing 3/4 more flow than we had, and we already didn't have a full load. So they ended up pulling one of the pumps. Somebody ground down the 7.25 stamping and wrote with a Sharpie 5.25. So it never got turned down. It never got machined. It never got changed. So this turned into a shit show. Now, mind you, we cut 40 days off to start this construction job. So in 5 weeks, we went from no hangers in the air to racks running. The fact that we even pulled that off, and then we had every obstacle in our way, like aka this pump problem. And pump impellers are not something you just go to the supply house and get. I mean, that's something that has to come from that particular pump manufacturer. They had to turn it on a lathe. Like, they had to make us 2 more and ship them out.
Yeah, because they're machined and balanced. If they're out of balance, then they're basically going to wear the bearings inside that pump.
Oh, you mean like taking a grinder to it and grinding off the old pump marking and writing with a marker? Like, I'm sure that was balanced real great. So then we go to do them, and me and my other startup guy, we pull both pumps out in the morning. They get there, the UPS package arrives at 9 a.m. We go get it out. I mean, I made them send seals and everything too. We're real careful about it. We change both impellers out, go to put them in. Well, lo and behold, the OEM didn't mount the pumps right, and now I can't get the pumps back in because the pump and the motor are not level. So they won't slide back in. So now I got to come along in a chain fall on the pump, trying to pull up on this pump to get it back on the same plane as the motor. Get it all the way back together, and I finish mine. I turn everything back on. I bleed it. I run it for like 5 seconds. I'm watching it, make sure everything's good, and then the pump seal blows in my face.
So if you can't tell by Kevin's voice, he's been on edge for a little bit for like the past couple weeks.
So yeah, then we had to tear it all back apart. Then I ended up changing a pump seal, which if most refrigeration guys don't do a lot of pump seal stuff. I mean, pump seals on water pumps are okay. Doing pump seals on glycol pumps sucks ass. It is a disgusting, messy job. And then, of course, there's no drain on this pump skid to drain it out. So I am laying in like 1/2 inch of glycol on the floor at this point. It's already on my back.
But it's not blue, right? that particular customer doesn't allow you to color the glycol, so you got that.
Yeah, I was not blue, but it was a pretty terrible day. And then, of course, that was Friday. We ran the racks for about 4 hours, and then I come inside and they're putting food and everything.
Oh, wonderful.
So that's how my week's gone.
Well, that was only like 2 days.
Yeah, out of working 7/16s. So so this week, guys, we were going to go over some questions have been asked. Fuck you, Brett. Stop laughing at me.
Sorry, I'm done.
I'm numb inside. So this week, guys, we were going to go over doing refrigerant retrofits. Some questions have been asked on some like basic retrofit stuff. I mean, it's maybe end up being a two-parter, but we're going to go over some basics on how to do a retrofit, kind of like in a rack application and maybe a C-line unit application. But we're going to go over the basics on how to do a retrofit from, what you should do first to what you should do last. So now, mind you, as we're going over this stuff, it's going to vary from customer to customer. I mean, you're going to have to follow customer spec, whatever they have. But I mean, every customer is different, whether it's Walmart, Costco, Target, Sam's Club, Albertsons. Everybody has a different spec and way they expect you to do this. I mean, I'm going to tell you right now, if you do a lot of these, you're going to get in a groove on how to do them. I mean, you just got to make that spec work around you. But I mean, there's certain ways to do these. I've done a ton of them. I mean, the branch where I work at, we do a massive amount of retrofits. I mean, we're running like a crew of like 3 or 4 guys. That's all they do all year long is gas changeovers.
Wow.
So, I mean, I like to do them a certain way and in a certain order, and I think it works pretty good. But I mean, it all comes down to what that customer spec is and just being organized. I'm going to tell you right now, the biggest thing with doing this is being organized. You have to be organized going into this, and you have to do your due diligence looking at the site before you do anything. You have to make a good material list. I mean, spending a day all day on site to try to find all this stuff and make a good material list is going to save you so much hassle in the long run when you go to start this. I mean, a gas changeover is not a little ordeal. It's not something you want to do on the fly. And it's a huge amount of prep work to do something that takes one night.
So let's go through first, like what you're really going to need. One of the biggest things, obviously, depends on what oil you're still going to need oil if you're going from a POE to a POE, because you still want to, get all that stuff out. You do want to make sure that you also have every single valve written down, which means looking at the refrigeration schedule if you're lucky enough. It also means going through and finding some solenoids that might be on top of boxes, because sometimes that gets let go. You look at the refrigeration schedule, it might list everything on the rack, but some certain valves, like especially with walk-ins, being that they usually typically shut them down when you open up the door, but they don't want to shut them down all the way back at the rack, so they'll put a separate solenoid on top. So make sure that you write down every single solenoid, every single ball valve. Certain customers require you to cut out said ball valves and put in new. Other customers, if they're Mueller valves, you can buy a retrofit ball valve cap.
I'm going to tell you that right now. Here lately, I'm cutting them out, especially on liquid lines. I mean, we had so many problems with the ball valve caps leaking. That I mean, it's to the point if the rack goes down and those caps cool down, they're leaking all over the place.
Yeah. So what would you also recommend as far as supplies?
So, first and foremost, anything with a rubber O-ring gets changed, especially high side components, solenoids, DDR valves, A8s, anything with a rubber O-ring in it. The Centronic, this is one that gets missed a lot. the Centronic tip sensors, the O-ring on the tip of the Centronic, that needs to be changed. I see a lot of that get missed, and I see a lot of nuisance oil problems afterwards, and it's because of that. All high side ball valves need to get changed. So liquid discharge, all high side ball valves. So that gets changed. Generally, suction ball valves, if they look okay, I leave them. If they're rusted and look like crappy or rounded off, I'll change them. I'm not attacking ball valves that don't look bad. Go ahead.
But that's also spec too. Basically you have to just follow whatever the customer is telling you to. There, Kevin and I are kind of overkill with a lot of stuff that we do, right? But it's all basically down to customer spec. If they're not going to change out the ball valves, then they're not going to change out the ball valves. Then they have to deal with it. You can, sometimes talk to the GC and they can talk about getting a change order about stuff that's leaking. But for all intents and purposes, you follow the scope.
Yeah, I've yet to see a customer on a gas changeover decline something like I say this valve needs rebuild. It's already leaking a little bit. We need to rebuild. I've never seen one deny it. I mean, because if it's leaking now, it's going to be leaking worse. But generally, all high side components, ball valves. I try not to do retrofit caps on high side ball valves. Your main ones, like your condenser ball valves, you don't want a high side cap those. You want to replace them because if they leak internally, you're up the creek. You might as well get them done when they're. I mean, as of lately, every spec I've seen come out, we've been changing all high side ball valves. So for most major customers, they want the high side ball valves changed. Solenoid valves, if they're after a certain date code for Sporlan, I think is it like 91 or 96. It's they went to the Wolverine gasket. You shouldn't have to change those. If it has a steel gasket in there, you shouldn't have to change them. I will tell you this. This is what we do on every one of them. We take the manual lift stems out and we Teflon tape them and seal them. Even though it's a knife edge in there, I don't know how many leaks I've seen out of the manual lift stems of solenoids. I see more out of manual lift stems after gas changeovers than anything. I mean, or you rebuild the whole manual stem. I've seen it also on customer spec.
Yeah, the manual stem. I think the Sporlan part number is the KM1, KM2, KM3, KM4, and KM5. There's 2 rubber O-rings on the shaft of the actual piece that actually spins into the bottom of the valve. I've already had, because the only thing that really changes in size is basically the shaft that actually opens up the valve. So like if you have a KM3 and a KM1, you could basically, reuse the shaft that's there, but then, just use the different piece that actually screws into the valve just to make sure those, if you don't have the correct one at that point in time, to change that out. What were you gonna say, Kev?
I don't think those O-rings are changeable, right?
No,
I never tried to change. No, I think you gotta rebuild the whole. I think it's pressed in there.
you'd have to use a pick in order to get it out. But like I said, like if I have one, like that bottom base for like four out of 5 of the manual stems, because the other one's for like the big bastard, the the big steel body valve. But basically, all the rest of them, they're the piece that actually screws into the valve is interchangeable with every single one.
You're talking pennies for what labor costs to rebuild those.
No, I get it, but like in the middle of the night, I'm saying if it's leaking and you only have one, you know what I mean?
Yeah, that's what I mean. So all high side stuff, solenoid valves, liquid differential valves, absolutely need to rebuild. I mean, I see more leaks out of those and the pilot assemblies on the liquid diff valves. So those need to get rebuilt. I replaced the pilot assembly. I do not change the O-rings on them anymore because, like, the same thing. It's that lift stem. I just changed the whole pilot assembly. That way, everything's new and there's no seal issues. So liquid differential valves, all high side stuff like that. So depending on what the customer wants, some suction stuff. If it's us right at scope, we generally do not touch the suction side. So if you have EPRs, we leave them. if they're leaking, I rebuild them. But I have had less leaks out of EPRs and everything else than anything. 99% of your leaks are on the high side. The only time I ever see some leaks on some EPRs is spoil and sort valves. The stem assembly has an O-ring underneath it for the sort 20 and sort 12s. Those will leak. Now, what we generally do is we keep a couple O-rings for those things around and we change them if need be. But generally, most like low side stuff, unless the customer is asking for it to be done or it looks really bad, we're not touching. And here's my thing: we have a lot of older stores. There's a lot of sort 12s on there, the old pink style, where they had the Phillips head screws on the pilot assembly on the solenoid. Get those out after they've been in there for that long.
So I have a question because I've probably done 5 retrofits, and so the pilot line, like on the sort or sport valves, basically coming from the high side, basically the pilot line. Do you find after the retrofits, because when you're going from mineral oil to polyester is basically a solvent, so all that stuff's going to wipe everything from inside of the pipe. Have you found that the pilot lines actually end up blocking up the filter there?
In 10 years, I've never seen one of those pilot lines clogged. I've never pulled a screen on a pilot line that looks bad, even out of some like junky 25, 30-year-old beat up racks. I've never seen a clog. Have you ever seen a clogged pilot line?
Once, but it was a piece of copper.
Yeah, I've never really seen like you would see inside of a TXV. Yeah, I've never really seen dirt in one. So I mean, I don't think I haven't pulled one in a long time, but I don't think that screens is fine. But yeah, so generally I'll keep some like supplies around for like sort 20s, sort 15s to rebuild, or sort 12s to rebuild those. If they're Flowcon A8 valves, I mean, I have yet to have one leak on the suction side.
Also beware, he was talking about rebuilding the solenoids. Make sure that you actually know what solenoid you're replacing, because if you have the biflow check valve, which we said usually is on hot gas systems without the check valve in parallel with it, the actual plunger assembly does look different than a typical solenoid. So I'm going to probably put this video up, but you can see this is the regular one. Has one hole in the bottom, and then if you look at the back, you can actually see it's fairly open. And then the other one on the back has a metal disc in there. And then in the front, there's 2 holes in there to allow it to be biflow. Make sure you're putting the right stuff in there.
Yeah. When we're doing this stuff, like, I'm gonna tell you right now, if you have a Husband Super Plus rack, just do yourself a favor, just gut the whole liquid header. If you don't do it, you're gonna have nothing but problems. So what we generally do is we make a whole new liquid header, and I will come in with my fitters. We'll cut every liquid line out at once. We'll pump the whole rack down. We'll cut every liquid line on the rack. We'll cut the header loose. We'll put a new header up there. We already have ball valves and solenoids welded on. So all we got to do is one connection, keep going through. Don't waste your time trying to seal every packed angle valve on a Super Plus rack, because, I mean, you could have 10, 15 liquid packed angle valves. Those things are going to leak like a sieve as soon as somebody takes the cap off. So that's the other thing, packed angle valves. A lot packed angle valves get replaced on all the high side stuff. And then I'm adding in 1/2-inch packs before and after the drop receiver outlet, before the ball valve, and then one on the discharge. And I'm using those for recovery and vacuum. So that way we can pull all the gas out of the rack as fast as we can.
Absolutely. Do you guys, when you do, because I've seen your setup before where you basically had that 5 horsepower, are you still using that where you're basically using a condensing unit and hooking it up? Or are you actually using rapid recovery? Do you guys have your own gig now?
So that is at my old company still.
Okay.
It is still alive and is yet to be killed.
Hmm.
So, I mean, lately they've rapid recovery or golden refrigerants, which I like them way more than rapid, but I would still rather do it myself. The If I have the option to do it myself, I can, because for what we pay for rapid recovery, I could have 2 more journeymen on site helping.
Gotcha.
So I would have 2 more journeymen covering gas and helping me than do that. But the whole thing, so all your high side components, CDS valves, certain CDS valves, I think it's a 16, has a O-ring in it. 9. One of those 2 does not have that crush ring and it has an O-ring. I want
Se-
to say it's 16
17,
or 7.
17, I think. So there's a 17 and then there's a 20. And any kind of flow con
Yeah.
valve, especially the oh my God, hold back valve.
Um, you don't want to rebuild those. Just rebuild them. Change all the internal O-rings on it. Like I said, suction stuff I don't really go over. So that's like when you're doing your walk, you want to find all those. You want to find your stuff in your cases. You want to identify how many Schraders you got in the cases. What kind of TXVs you have. Uh, Another thing that gets missed a lot is BQ valves. If you have Sporlan build the valves, there's O-rings on those cartridges. I'm going to tell you right now, you should change them. I don't every time.
Well,
I
like you
mean,
said, depends on the spec, right?
the last job I did, we had BQ valves in every case, and we had one valve out of, I don't know, 120. We had one valve bleed through the O-rings, and it just bled through the equalizer line. And for what it would have cost to change all those, swapping one cartridge versus 120 cartridges, you're talking $30,000.
Yeah.
Maybe if not more between store labor and our labor. So it just depends. I mean, that's a case by case basis. So after you made your list, you've got your oil, you've gotten your parts. When first thing I get on site, when that first day I'm having a couple guys get there. 2 guys are leak checking the entire day. All they're doing is leak checking before we even start. We're going to find all the leaks before we start. We're going to make sure every little leak is found and noted, and that way we can take care of it. And then whoever's running the job, a foreman, is counting parts, organizing parts, setting up a table with all the parts, marking parts, where they go, all that stuff, making sure you have everything you need. Because there ain't nothing worse than starting a job and realizing, oh shit, I just took this valve apart and I'm missing an O-ring. Okay. Sporlan also makes a retrofit guide for every one of their valves with an O-ring part numbers on it. So a lot of times, like, I'm not ordering a liquid differential valve rebuild kit when I could order 2 O-rings that are $10 versus a rebuild kit that's 500. So I'll have Brett put that up there when he posts it. There's an actual every single seal that's in every valve Sporlan makes is on there, whether it be a kit for them or stuff like that. I mean, Danfoss, I don't know what they have, but so every seal is on there, so it makes it a little bit easier for you to identify stuff. So after we're done leak checking and we're done with all that, we start the oil changes. We do this a little bit differently than most customer spec. So when I go to do the first oil change, we shut down the compressor. We use the oil pump to drain it out, hook a hose up to it, let it drain out with the oil pump. Shut the oil pot off, let it drain out completely. 2 things I'm doing. I'm testing the oil safety. I'm waiting for the oil safety to trip. I'm watching it. I'm testing the oil safety to make sure it works, make sure it trips out, but just don't let it run dry for too long. And then once it's all out, I'm pulling the sump screen out. I'm going to clean the sump screen. We're going to start off this rack, get as much trash out here as we can. We're dumping POE oil in there. I don't want to start, doing a gas changeover and I have some springs that are half clogged. Now they're going to be fully clogged. I want to try to get all that trash out of there. Then I'm taking every single connection off his compressor. I'm taking the high and low pressure switches. I'm taking any threaded connection. I'm blue monster taping it and I'm nylogging it. Every single threaded connection. I'm taking off the oil pot. I'm changing the Tetra seal and the O-ring on the oil pots. You want to change the O-rings there, and then I'm taking off the Centronic sensor. I'm cleaning it, and I'm changing the O-ring on that. I'm essentially starting off with a clean compressor, all new threaded connections, no leaks from there. And then another one that gets missed is I'm changing all the super hoses out. Generally the armored cap tubes or those new reef hoses, I forget what they're called, the ones that Hill Phoenix has been using, the gray ones.
Oh, okay.
Where they make them themselves. I forget what they're called, but no rubber hoses, no yellow jacket hoses. None of those yellow. Go ahead.
You have to watch with them anyway, because I mean they got temperature ratings. I mean, we were doing a bunch of at an old company that I was working at. We were doing a whole bunch of PMs, and we were getting yellow super hoses, and guys were putting them on the discharge line, and they were melting and just rupturing. So make sure if whoever is buying whatever, just make sure you're putting the right hose for the right application.
Yeah. We use a lot of the armored cap tubes. I generally only buy the ultra tubes, which are the standard Johnson Control cap tubes you get at the supply house. The armored ones are not the ultra tubes. The ultra tubes have no Schrader depressor in them, and they're thicker. If you ever worked at a Target, like if you ever noticed like the high pressure and low pressure switches, the Johnson Controls cap tubes are like way thicker. Those are the ultra tubes. So that is a full flow 1/4 inch tube with armor around it. The normal one is a cap tube still. Okay. And this is another big thing. If you are using ones with Schrader depressors in there, you have to break that Schrader depressor off before you change that hose. If you do not break that Schrader off, it will get stuck inside of a fitting, and they block the fitting.
I've seen it where basically it caused the high pressure, low pressure switch not to work at all. Today's episode is sponsored by the new Refrigeration differential pressure monitor from Westermeyer Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace the filter? Wait too long to service the filter, and you could end up with nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Refrigeration RDP-01 differential pressure monitor is available now with Westermeyer Industries. To find out more, email sales@westermeyerind.com. Once again, that's sales@westermeyerind.com. Look for the new pressure differential monitor, available now.
Correct. Now, while you're doing these oil, like one thing to do before this, if you have Carlisle compressors, you need to check the date code on the oil pumps, because certain date code oil pump Carlisle compressors cannot pump POE oil. So we had this problem at a store. It was from the early 90s. They ended up having a bunch of oil pumps on there that were not suitable for POE oil. So I think it was like half the compressors on the rack. We ended up having to put oil pumps on. And I think we ended up losing the majority of them, which Carlisle told me was going to happen. The customer knew it was going to happen. So I mean, what ended up happening, we had like shit oil pressure on all of them. So even with the upsized oil pumps, still was the issue. Copeland's, you aren't going to have that problem on. Bitzers, same thing. So as you start doing these oil changes, after you drain the first compressor down, you get it all cleaned up, you get it ready to go, fill it back up with oil. Okay. Go to the next compressor. You drain that compressor down, do the same thing, fill it back up with oil. You keep going on all of them. And then as you're moving to drain the reservoir down, you're going to fill up with oil. Time to get to the last one, change is done. Okay, you're going to let it circulate for the next day, you're doing another rack or doing something else. Always start with oil changes. You want to get your second oil change in. It just depends on the customer. We've had a customer where they said technically they one suitable clean. If your oil looks like shit, do yourself a due diligence. If you got dark, burnt R22 oil, get that stuff cleaned up. Do 2 or 3 oil changes. This is where you're going to save, some service guy down the line a big headache in yourself. Get the oil clean. Okay, after the oil's clean, then I start rebuilding valves. It depends how I try to do all the burning first. So I'll try to much pipe as I can, put out ball valves and just burn in new ball valves. So I'll do all the liquid ones. Depending on how big the rack is, if it's 10 circuits and I can get to them, I may pump the whole rack down and do all liquid ball valves at the same time for the circuits. Depends. It all depends on the situation. We may bite off chunks. We may take like 8 down at a time. And it also depends who I'm working with. If I'm working with a guy that I trust and, a good fitter, we might try to tack a little more. It just depends on how it is. And then obviously, go ahead.
I had a question because you were talking. You went right into it. And so one of the things I do with oil changes is I basically, because you said empty the oil res at the second to last compressor. What I like to do, this is just different, is basically I empty the res at first and basically put brand new POE oil in it, and basically utilize that for every single time that I empty one. I got the oil pump already hooked up. Are you opposed to that? You agree?
I do the same thing. I mean, it depends on the situation. I mean, I had this really nice oil pump that ran great till this week. So that I used to use that was a casualty of a lift. So I have a gear pump that I was using that I was, you just hold the trigger down and we were pumping oil in the res, pump it in that way. It all depends. I mean, sometimes it's easier to pump it in. It's just, I filled up recovery cylinders full of oil. We took a 50-pound recovery cylinder, put 5 gallons of oil in it and used discharge pressure, push it in. That works great.
I have a pump that I got from Granger. I'll put the part number up on the Advanced Refrigeration Podcast Facebook group. But basically, it's just a regular hydraulic pump, and the shaft's open, so I basically just hook it up to the thing, and it'll go against like an oil separate, like a high pressure oil separator. So it'll go against discharge pressure, no problem. I've had no problems with it.
Pump. That's all it was a carburetor pump, a soda pump.
Huh.
It'll push against 340 pounds. So that's what I was using. But so then I started tackling the ball valves. My whole goal when I'm doing a gas changeover is the night of the changeover, I don't want to do anything. I want to drop the gas out, pull a vacuum, drop the gas back in. I do not want to change high side ball valves. I know a lot of guys, they'll try to push the night of the changeover. They'll have 6 or 7 guys in there working. I don't want to do that unless I absolutely have to. I try to avoid that at all costs. I'll do as much prep work as I can to try to avoid that, because that is a stressful night for everybody. And you're under the gun. You're about to lose product. I mean, it's not a fun time. So I try to do everything. I mean, there is ways to force gas in places and hide gas in the rack. I generally have like 2 or 3 recovery machines or recovery cylinders so I could pump out the condenser. I will drain the condenser, and I mean, usually in like an hour and a half, I could take a condenser down max. I mean, most of the time it's a half hour, 45 minutes, and I could change the high side ball valves, get them done, fire back up, let it run for a couple hours. Then I go for the receiver ball valves, push all the gas upstairs. It's all about pushing that gas around the system and getting all these ball valves done ahead of time. It's just going to make your life a ton easier getting all these ball valves done ahead of time.
Because tell them what's going to happen. Basically, if you don't plan ahead and get these ball valves done right away, you're going to try to pump the gas and put it where you don't want it at that point. And all of a sudden, oh shit, you can't, you can't because the ball valve's now not holding.
Well, not even just that. When you go to do the night of the changeover, like I helped another guy do one. Was it last year? And the night of the changeover, me and 4 other fitters show up. There was already 3 other guys there. So now there's like 7 guys working in this rack room. And we're running like 5 torches because we're doing 2 receiver ball valves, 2 drop leg ball valves, 2 discharge ball valves, a split valve, a main liquid header ball valve. This is all like 2 and 5. So, and it all had to be cut. It all had to be on braze, and it all had to be used come alongs and everything else to get it apart enough to get ball valves back in and heat it back up and force back in. So you're talking, it took us a good 5 hours after we got the gas out of the rack. So now you're talking the rack's been down for 8-9 hours.
And you remember it's
vacuum.
Good. Yeah, it's playing beat the clock too, right? Like, most customers, they will yank the product. Will they yank the product out, or are you doing dry ice with everything?
Dry ice. I've yet to come to a store where they yank the product out.
So night of the gas change out, do you do what I do where basically I'll run the rack all the way down to nothing, like just as far as suction pressure go as low as humanly possible. And then basically so you have on top of the dry ice, you're basically, freezing the crap out of the coil. So it gives you a little bit more lead time as far as, how long you have the clock.
Yeah. Frozen food, I really don't give a shit. It usually is fine. I make them pull the ice cream, but you throw a little bit of dry ice in there, most frozen stuff's fine. Bunkers, I absolutely make them pull the bunkers. I don't give a shit what they say. That's on them. If they don't want to pull the bunkers, they're going to be throwing it away anyway. Fresh meat, all fresh meat gets pulled. Deli, sometimes they pull it. Open dairy, we tarp everything and throw dry ice in there. But fresh meat and bunkers, if they don't pull it, they're going to be throwing it away, and you don't want it to be your fault. So make it their fault. So that's one thing. And then, like I said, everything needs to be done before the night of the changeover. So after we get all the burning done and we're done with all these ball valves, generally what I do is try to have 2 apprentices there. And while we're pumping stuff down, have them downstairs working in the store. So to change the Schraders in the cases, verify that there's no solenoids in the cases hidden somewhere, old remodel, whatever. And then at the same time, I make them clean the TXVs, remove any dryers that are there if they're there. And if the customer wants them back in, they get put back in. And then I make them seal the bottoms of every TXV. I make them turn the stem in. If it's a G body valve, make them tighten the packing nut up. And then I make them Teflon and Nylog the bottom of every TXV cap. And then we will pull vacuums on whatever we got down, start it back up, move on to the next section of the store. So you got to have a real good crew going. You may have 2 guys upstairs burning pipe, 2 guys downstairs changing Schraders and doing stuff in the cases. I generally mark the cases like with days that we're going to have in the spot that I want pulled for the store. If it's, I get to mark 2 or 3 spots, like I'll mark it up with masking tape. I'll write Tuesday, 9 a.m. I need this product pulled. Wednesday, 5 a.m. This section's got to get pulled. Work with the managers and kind of try to sweet talk them a little bit. And so that way you get this product removed out of there. So you can get the guys in there to rebuild this stuff and change the stuff and move quickly. Everything's about moving safely and quickly without leaving stuff off or fucking up.
The after you get the old gas in, the new gas in, do you guys do one final oil change?
No. Once the new gas is in, as long as it looks good on the refractometer for the oil, it's good.
So
I will say this. If you're going to do this, change the oil separator. Everyone that we've changed the oil separator on has gone so much better. It's your chance to resize it. It's your chance to put a temp right in or a filtered separator in. a coalescent separator or downsize a centrifugal separator. And I'll tell you what, I just did 2 stores with Myers. It was the kind of experimental at the time, and they're released now. They're filtered reservoirs. We had a rack that looked like motor oil. I mean, these 2 racks were the nastiest mineral oil I've ever seen in my entire life. So we put in 2 filtered oil separators. We were blowing the separator cartridges like every 2 to 3 days. We clean up filters we were blowing. Ended up putting the reservoir filters on. In like 2 weeks, this oil was like clear. And we did a couple changes, and it still looked like shit. It still looked terrible. The coalescent filters were coming out black as a tire. I mean, the oil just smelled horrible. I was covered in it daily, so I also smelled like it. So we ended up putting the filtered reservoir in. I changed the filter on it once. It looked nasty. The second time, it looked beautiful. I mean, the oil cleared up big time. I'm a big fan of this filtered reservoir. The more you can filter the oil, the better, and the better all this is going to be.
So what he was talking about before, the United or whatever supply house you go to sells a refractometer that basically tells the percentage of polyester and mineral oil left in there. And what are most of the spec? Is it 80-20? Is it 90-10 as far as percentage of POE and mineral? Is it
5%? No more than, most of the time it's no more than 5% leftover mineral oil. Okay. So after like your 2 second and a half, I mean, depends on how diligent you are about getting it all out. Second time, it's pretty good. So while you're doing all this stuff and you're doing the oil changes and you're starting to drop stuff out, we always rebuild the oil floats or change them on the oil separator. If it has a float, I drop the float, clean the screen. And most importantly, while you have this down, check the screen, make sure it's not torn. If it's got a stock up in there, easiest way to get them to change the separator. Just screen's torn, they're getting a new separator.
Yeah, and they can become.
Chance to.
Sorry, they'll become torn, whether it be usually from overfilling, like just of debris inside the system, or the other thing is discharge valves getting thrown in there, basically tearing up the screens.
If you find discharge valve at the bottom of a separator, and it's a normal standard separator, they came from somewhere. So you best get your head up in there and look, because that sock's probably torn. So
especially when you're there and you see a whole bunch of empty oil cans all around the rack, right?
Yeah, you know you're finna get screwed. So just keep in mind, get the oil system where it needs to be. That's a big thing. And then you start with get the liquid good. So I generally Sporlex a sleeve that goes on the end of the micron or on the new style filter dryers. So the one with the rod running down the center with the screen on it, not the ones with the screen on the end, the newer style. They make it's either 1 or 2 micron sleeve that goes over that screen. That sleeve is like twice as fine as like the old screen at the end. That sleeve will plug up before the dryers will. That screen will catch everything. You want to get all that crap out of there. And then you want to change your suction filters. I mean, generally, they're removed. If they're not removed, you want to put them before you start this. So if you're at a Walmart, they're supposed to be pulled. So put suction filters in before you start doing oil changes. Check debris. And then the night of the changeover, you're going to change all the filters again, oil filters, liquid filters, suction filters. You're going to change all those. Now, when it changeover night, like Brett said, you're going to run everything down to temp. You're going to get everything down. You're going to get that rack down to the bare minimum, meaning like you're starting to river the side glass a little bit. Shove it in another rack, put it in recovery cylinders before, let it run like that. I will use the rack to recover as much gas as I can with push-pull. So I will start pumping down into the receiver. I will try to force all the gas out of the store. I want every bit of gas in the rack. I don't want anything in the store. We don't want to try to pull in a store that would take hours. You want to try to trap all the gas in the receiver. So what you do is you shut down your liquid, let everything pump down. You force the pumps on, run them down to like a pound, half a pound, and the entire time you're going to be push pulling liquid into tanks. So whether you're push pulling liquid to rapid recovery or you're push pulling the tanks yourself, you're taking liquid out into the tank through the dip tube. You're going to put it in the dip tube of the tank, out the suction side of or the vapor side of the tank. You're going back into the either another tank using a recovery machine or using the suction of the rack. So what you're doing is you're venting out that tank, allowing liquid to come in. I'll do 6 tanks at a time. Big thing when you're doing this, if you're doing it by yourself, take wire and ground all the tanks, or else you will short out your scale.
Yeah, you get a static electric charge from there, and basically, I don't know if you've ever filled a bunch of refrigerant into a rack, and you go to touch the gauges and you get electric shock. That's what that's from. It's just the static electricity, because the refrigerant's just sailing through so much. Also I know Kevin, especially when he's doing it by himself, where he's not using an external, rapid recovery or whatever. He usually does put all the cylinders in the freezer to basically, help the process, right?
I generally don't do that anymore. I haven't done that in a long time.
Oh, you suck.
I mean, it's never close. So, and by the time they get out and get set up, they're already warm again.
Yeah.
I generally, especially when I had succubus, I mean that compressor we would just put straight liquid in the suction.
It's scroll it could take it.
Oh, it did. It just, I mean, I think I did 11 gas change outs with that thing. I think it was like 14 racks total. It was more than that. It was probably like 16 or 17 racks. That thing probably took 30,000, 40,000 pounds of gas. I mean, and it was we would just put some oil in every once in a while.
Just keep a sight glass.
There wasn't even that. It would be like, oh, it's making noise. Better put some in there. And then I use a water cooled heat exchanger. I took I got on eBay. I bought a plate and frame heat exchanger, or I'm sorry, a brazed plate heat exchanger. For everybody starts freaking out.
Correct terminology.
I bought a brazed plate heat exchanger, like a 36,000 BTU heat exchanger for like $40, and it's got half-inch. I put half-inch flare male ports on it, and then I got a garden hose connection, so I run a garden hose through it. I could get refrigerant coming out of this thing that's a degree over water, 2 degrees over water, depending on how cold the water is. So I mean, it runs great. So I'll use that to cool down the tanks. The refrigerant going to the tanks. If you keep those tanks cool, everything goes quick. I mean, you're not going to want to use a standard recovery machine for that. It's going to take forever. I mean, you're going to want to use something that's a little beefed up, something a little bigger, or a condensing unit, or another rack. So, and then you're going to want to start pulling a vacuum as soon as you get the gas out. I mean, most of the time, a recovery company will get you down to like 5 inches of vacuum because they aren't paying attention. Where you hear the tanks going off because they just hire the greatest people to do the recovery stuff. The last one, I think the guy blew off the reliefs off like 5 tanks.
Damn.
So, yeah, Golden refrigerants. They're out of the Midwest. They showed up with 4 1,000-pound tanks on the last Costco I did, and 2 electric liquid pumps. He pulled 1,700 pounds of 22 in 38 minutes.
Damn. And that's why you use. Good.
Before we even realized that the rack was in like an 8-inch vacuum. And that was just with liquid pumps, but he didn't have to stop. There was no switching of tanks. There was no screwing around. He had 2 1,000-pound doers hooked up, like big, like tanks you use for a chiller, hooked up, and it was gone instantly.
Yeah, if anyone's never seen a tank that's 1,000 pounds, it technically looks like a 6 foot propane tank. Is really what it looks like.
Like
Say it again.
Looks like an old school atom bomb.
It does. We used to have a certain big box warehouse that I took care of that over in Jersey, and they would hit. It was a industrial system, so they used screws, but they used R-22, and they had bomb. We called them bombs. They called bombs of refrigerant over there all the time because they would, shippers are notorious for hitting loading dock evaporators. So you hit one, you get your ass there. They've hopefully have it shut off by the time you get there, and we're putting in 2,000 pounds of refrigerant because on a centrifugal system, there's thousands of pounds of gas.
Yeah, big hoses. That's another thing. Like getting 1/2-inch hoses, ditch the 3/8 hoses, no 1/4-inch hoses. You want 1/2-inch hoses, minimum. The bigger the hose, the faster it's going to flow. So, and the faster you're going to move that refrigerant out. So, and same thing with recharging it. So that's where these 1/2-inch ports come on, because you spur off and you pull from the receiver, you pull from the before the A8, after the A8, and you pull off the discharge. You pull all the high side points of the rack. You can pull this thing down instantly. You get around your check valves, you get around all that. So that's where these 1/2-inch ports come into play. And then likewise, depending on the customer spec, some of them make you pipe the vacuum pump into the rack. I absolutely hate that. It's a pain. It's in the way. But if customer spec, it's customer spec. Me personally, I like blue vac hoses. They're flexible. I could use them on the 1/2-inch packed angle valves. I don't got to pipe the rack into the vacuum pump into the rack. It works great. And then all these people are stuck on these belt drives. To hell with belt drive vacuum pumps. It's old, antiquated technology. Even when they're customer spec, I've been they've been letting us use these rotary vane vacuum pumps. So Navac, Welch, they both make them. Me personally, I like the Navac one more. But we have like 432 CFM Welch pumps. They have KF fittings on them, so they adapt right to those blue vac hoses. So I have this. In my last shop, we had a stainless header. Here I have a 5-port adapter, where I could take this thing, or I could put a ball valve on it that we welded onto a KF fitting, which are designed for vacuums, and then we could pipe it into the rack. But this rotary vane vacuum pump weighs about 65 pounds for a 32 CFM. A 32 CFM belt welt drive weighs more than me.
Say again, I missed that. You broke up a little bit.
I think a well vacuum pump, a 32 CFM, probably weighs like as much as me, probably almost 250 pounds, 300 pounds for a big Welch 32 CFM. Those things are heavy. The rotary vane pump is 56 pounds. And it's twice as fast. So, you want to get that vacuum as low as you can go, as fast as you can go. I'm going to tell you right now, most customer spec is 500 microns, but food temperature dictates microns every single time. No, nobody's going to say a word about a rack getting down to 1,000 microns before they have to throw away, $15,000 worth of ice cream.
Now, one thing that we did leave out is, knowing what gas you're coming from and going to. So if you're going from, because sometimes they'll take a medium temp 404 rack and they'll throw in 448 or 449. That seems to be the new go-to gas. The power heads have to be changed. Absolutely have to be changed, because otherwise, there was a certain customer that didn't have it as spec when that gas first came out, and they basically were having issues that they were having erratic swings. They were having major flood back. And basically what it was is, you could see when the superheat would go from like 2 degrees to 18 degrees and it would just hunt super bad. And I had said to the customer, I said, I know it's not in your spec. I said, but let's just try it on a lineup. Because you could actually see as the swing of the superheat went, it was basically going up and down with the discharge air temperature. So we decided to just change one lineup, and sure as hell, we changed it, and it smoothed out incredibly. So if you're, like I said, if you're going, 22 is more comparable. I'm sorry. Yeah, 22 is more comparable to 448 and 449 than 404 is. So change it out. Some customers, I think you really should probably change it on low temp. Some customers are like, let it go. Because I mean, they can adjust the valves down and have them work. Not perfect, but okay. And so that's just something extra to look for. If knowing what gas, if you're starting from 404 to 449, just be aware of that as well.
Yeah, I mean it's a big thing that particular customer didn't do, which bit him in the ass. So I mean, there's a whole nother. Oh, this is one thing we left out: liquid injection valves, like particularly man cooling valve from Copeland. Every single one needs changed out, and on loader stems. Those are two missed ones that missed a lot. The demand cooling valves leak like a sieve if they're not changed out.
You did say, yeah, you said unloaders. I'm sorry. Because
Yep.
basically that piece in between where the brass and the steel screw together, that ends up leaking real bad. Have you ever had to do a belt-driven store?
No. No, I've never done a belt-driven store, so
I'm not
we
sure
don't
if the
have any of that.
shaft will have to get replaced or not.
I would think so.
The other thing is if you have I know there's a couple stores on the East Coast that had a 22 that had to get converted, and some of those stores had the pulse width modulation valves. Those you better get the rebuild kits for, and you better rebuild all of them.
At that point, that's a remodel. Well, I think we should probably end up making this a two-parter, and we can go over the whole startup sequence on the next one. Because there's a whole nother on the backside of actually starting up after the retrofit. So we'll meet that next week's podcast. So thanks for listening, guys. Have a nice night.
Good night, guys.